Hello, we're doing checkpoint 5.24. Here we have a triple integral and they want to see what this integral is over the solid E, where E looks like it'll be a sphere, radius 3, and that's described as x squared plus y squared plus z squared is equal to 9. Alright, so if we're going to set that up, what we want to do is, because it's a sphere, you can really integrate with respect to whatever variable you want first, but here we'll just do it with respect to z. And if we solve for z here, we're going to get 9 minus x squared minus y squared, and then you take the square root, you'll get a negative part, which is the bottom part of the hemisphere, or the bottom hemisphere. That's the negative square root of 9 minus x squared minus y squared. And then the positive part is going to be the top part, which is positive the square root of 9 minus x squared minus y squared. Now, given that, what we need to do is look at the shadow on the xy plane, because you've kind of taken care of what happens in the z components. So just on the xy plane, you will have your x squared plus y squared is equal to 9 circle. And if we integrate over that circle in 2 dimensions, we can do it again with respect to x or y first, but let's go ahead and do y. And if you solve for y here, you're going to get the positive and negative 9 minus x squared. And so the negative part would be in the bottom, and then the positive part would be on top. So your limits could just be from negative root 9 minus x squared to positive square root of 9 minus x squared. And once you're left with that, you're just going to go from constants, negative 3 to 3. And those are going to be your x limits. And therefore, we should be able to set up our integral. Our integral here would just go from the integral minus 3 to 3, the integral minus square root of 9 minus x squared to positive 9 minus x squared, and then negative square root of 9 minus x squared minus y squared to positive 9 minus x squared minus y squared. F of x, y, z is our integrand, and here we're going to integrate with respect to z first, then dy, and then dx. So that is our triple integral written with the generic function f of x, y, z. Now, hate to do this, we're going to have to rewrite the whole thing again from minus 3 to 3, square root of 9 minus x squared to positive 9 minus x squared, negative square root of 9 minus x squared minus y squared to positive square root of 9 minus x squared minus y squared. The integrand now we're going to consider as 1, and we're going to go dz, dy, dx. Okay, let's integrate this with respect to z first. And with respect to z, it's just going to be z, because the integrand is 1. And we're going to evaluate this at these limits, so I'll just put a couple of stars there. In any case, you put this for the top limit, you're going to get the square root of 9 minus x squared minus y squared. And then after that, you're going to have minus negative, so that's going to be a positive, and then that's the same thing. So you're just going to double this quantity, and so that is going to be our integrand. The integral of the inside, and so now what we have left is the outside. There's still 2 integrals left. Integral from negative 3 to 3, and then negative 9 minus x squared to positive 9 minus x squared. And then our new integrand is 2. Let's put the 2 out here. And then square root of 9 minus x squared minus y squared. And then here we're going to go dy dx. That's our outside 2 integrals. If you take a close look at this, we see that this is really a circle on the xy plane that has a radius 3, a disk. And so given that, I think I would much more interested in transforming this into polar coordinates. So let's say we're going to go to polar coordinates. Our disk that we're looking at is has a radius of 3, and so your r limits, we're just going to go from 0 to 3, and then your theta limits go from 0 to 2 pi. All right. Okay, so we can redo this integral. There's a 2 out here, and then now we're going to transform this into polar coordinates, and the x squared plus y squared are both negative. That can just transform to r squared. And then the dy dx, and remember that there's an extra r that comes out of that. And then the r limits are going to go from 0 to 3, and then the theta limits are going to go from 0 to 2 pi. Okay. The other neat thing about this is that there's no thetas within the r integral. There's no, so we can take that outside or to separate this. And so we will have a 2, and then the integral from 0 to 2 pi of d theta, which will end up being just 2 pi. And then we integrate from 0 to 3 of this quantity, 9 minus r squared, and an r dr. Okay. Again, this is just going to be 2 pi, the first integral. The second integral is going to require a little bit of a u substitution. So if we, let's say, let u equal to the thing inside of the square root, u equal to 9 minus r squared, du is going to be negative 2r dr. There's an r dr there that's going to get replaced. There's a negative 2 that comes out as a negative a half, negative 1/2 the integral of u to the 1/2 power du. And then we integrate that, we get 2/3 u to the 3/2 power, and then divide by 3/2 or multiply by 2/3. So if you multiply this by 2/3, you're going to get the 2 would cancel, and then you'll get a 1/3 left over, u to the 3/2, and then u to the 3/2 is going to be, well, let's say 9 minus r squared to the 3/2 power. And we'll evaluate this from 0 to 3. All right. Let's see, if we evaluate this, if you put 3 in there, you're going to get 0. And if you put 0 in there, you're going to get a negative 1/3. And then, oops, let's write this in a place where it's visible. So we're going to get a 1/3, or we're going to get 0 for the first part, minus negative 1/3. And then we put 0 in there, you're going to get 9. 9, the square root of 9 is 3. 3 to the 3rd power is 27, so that's 27. And cancel, you're going to get 9. And so positive 9. So what do we have left? We have 2 times 2 pi times this thing, this integral, which we found to be positive 9. Okay, so 4 times 9 is 36. This is going to be 36 pi. All right, so that is your answer for that. But let's compare it to the volume of a sphere. If you remember the volume of a sphere formula, this is going to be 4/3 pi r cubed, and with a radius of 3, we're going to get in this particular case 4/3 pi times 3 cubed, and one of the cubes would cancel. This would just be 9, so this is 36 pi again. So that matches, and this in fact, with the integrand being equal to 1, in this case we are indeed looking at a sphere, the volume of the sphere with the triple integral. All right, okay, I hope that helps.